Good morning, everyone. So we are day 2 of presentations. Had some good presentations on Monday. Looking forward to some good presentations today. Before we get started, I did want to clarify something because I've received a few questions on this. So the question was, do the notes that you're taking on these presentations need to have a specific form? The answer is no. If you want to take them as paragraphs, that's fine. If you want to take them as bullet points, that's fine. If you have a clever way of doing it by memes or emojis, as long as I can understand it, that's absolutely fine too. If you are handwriting notes, you don't even need to type them out. You can just take a picture of your notes and put them in bright space as an image. All I really want to confirm is that you're paying attention to the presentations. That's the only goal here, is that everybody's engaging with the presentations as opposed to doing their own thing. So please make sure that you just get those uploaded. I would recommend that once we finish our final presentation on Friday, which will be only be about a half day on class, that you just upload those and be done with it. All right, so we're going to go ahead and start in. So we got team baseball and softball, I think is what I call them, but you guys want to start out?
Yeah, you can go for it.
Be on the camera all the time.
I think we're both gonna be on the camera.
Oh, yeah, thanks. That's the problem with being old, is I forget to do stuff like that, so. There we go. And let me do this, because it's just distracting to the people presenting. Hello, everyone. Let's just do that. Yeah, I still have the image.
All right, so for our presentation, we're doing AI and fraud detection. I'm PJ. I'm Luke. I'm Isaac.
I'm Olivia. I'm Nina.
And I'm Alex. All right, so to start, what is AI fraud detection? So AI fraud detection is the use of machine learning to identify fraudulent activities in large data sets by training algorithms to be able to recognize patterns and anomalies that signal possible fraud. All right, so the history / timeline of fraud detection in AI. So fraud has been pretty prevalent for millennium, as early as the ancient Greeks. And then, so the first type of fraud was like an insurance fraud. So someone was took out an insurance policy on his boats and then tried to sink the boats and take all the money from it. So it's like a little bit of the timeline of fraud detection. So the 90s brought simple rules engines, which were basically just simple inputs generating very simple outputs that detected simple fraud. And then the 2000s kind of built on that, and by building neural networks, which are like statistical models to be able to find more advanced types of fraud. And then now in the 2020s, generative AI, which is basically just keeping to build on the neural models to find even more serious instances of fraud.
So today, or as of 2023, it was projected that between credit card fraud, identity theft, and phishing scams, there was to be about $38 billion in losses. As PJ mentioned, they use anomaly detection, and that's kind of like the first line of defense. It's just looking for data points that deviate from kind of the trend lines. But it has its limitations. AI kind of helps with that in terms of speeding up the process and being able to see it in see those anomalies in real time. And then it goes on to, or companies can use natural language processing because it's able to read textual data to kind of deter fraud and sniff it out. And then deepfakes are becoming more and more common. You might see it on social media where it's like a politician or someone giving an interview, and they change the way that they speak or the words that they're saying. That's also used in fraud. So it's important to be able to use deep learning because deep learning is able to use biometric liveness detection to make sure they're dealing with real humans and not something that's created to be an image of one.
So traditional fraud detection techniques that were implemented before AI was available and affordable for many companies is the rule-based system. And the rule-based system is basically just predefined rules based off of historical data and like company regulations. And basically these rules are based off of location, frequency, sender, receiver, timeliness. And if those rules are flagged, obviously they have to go in and manually review them. So it is less effective and more timely. Along with that, rule-based system also creates a lot of false positive because of the constraints of which these rules are put in. And specific types of AI techniques in detecting fraud. One is anomaly detection, like Luke said. It is a type of supervised machine learning. It detects patterns in data and through like the data that it has, and it determines whether there's normal patterns and fraudulent patterns, and those fraudulent patterns are flagged for review, and it is very cost effective and much faster than the rule-based system. Along with that, this is mainly used with banking and insurance and like financial transactions. Another type of AI technique is feature engineering, and feature engineering is another type of supervised machine learning that basically it creates characteristics for users, and it like looks at your IP address, the time that you spend on the website, and cross-references that with social media sites to make sure that you are who you say you are. And if you like if you stray from your characteristics, then you are flagged and you need to be reviewed for potential fraud. Along with that, there is continuous learning, and continuous learning is just adapting. So it's a continuous inflow of data, and as that data comes in, the machine adapts to that data, and it is continuously reviewing new patterns and updating. So as fraud evolves, the system also evolves with it. So some implementation, these are just a few companies that specialize in fraud detection, AI fraud detection. So Xeon is basically, it assigns risk percentages to users. So it uses like feature engineering to look at your characteristics. And then based off of that, you have a risk percentage associated with that. And this is mainly used with gambling and financial services, just to make sure like you haven't committed fraud before, or you're not like highly suspect. Along with that, Datadome detects and mitigates fraud attacks for apps and APIs and websites. And Datadome uses anomaly detection. And then Unfido, I think that's how you pronounce it. It does identity verification. So like whenever like you log into your bank account, like, and it uses like your Face ID, it uses that. So it uses facial recognition and biometrics and data visualization to be able to identify your identity. And then GeoComply is another common type. This is used for sports betting. It uses geolocation to identify you are where you say you are, because like with sports betting, it's not legal in all states. So.
Okay, I'm going to go over the common types of fraud that AI detects. First is card fraud. This is the biggest one, and this is where the cyber criminals use the bot to test stolen card data with small transactions. And the way that AI is able to handle this is they're able to notice the small transactions through the algorithms to find the anomalies in this. The next one is the fake account creations. And I'm sure a lot of you have seen this on Instagram or Twitter. This is where you just get a bunch of like spam accounts. I know I've got comments and just a bunch of like symbols, and this allows for the hackers to be able to skew information on social media so they can like spread false information, spread malware, and ruin analytics based on just creating a bunch of accounts. And continuing with this, account takeovers, this is where they hack into your own account. This has happened to me on Instagram before. They log you out, and they do this to be able to target your personal data. And this is tougher for AI to handle because it's not always visible until the hacker does something. They'll post on their story to notify people. And then finally, credential stuffing. This kind of leads to all three of these, and this is where bots attempt to guess your username and passwords. And then the benefits of AI, there's real-time detection. The reason AI is so good against people is they can block threats in milliseconds. And the reason is it gets better over time. As we talked in class, reinforcement learning. So trial and error. If they make a mistake, they're not going to make that mistake again. So they'll be able to fight against that type of fraud. And then it just helps the company overall because it saves the employees time investigating the threats. And so they don't have to focus on the fraud and they can focus on more important things in the company.
And then the future of fraud detection, the role of AI in fraud detection is growing just because of the amount of digital transactions we see today. We can also see this number growing in the future. One of the rapidly evolving AI types that Luke kind of talks about already is natural language processing. This is where the AI type learns the usual patterns of customers, and the AI computer algorithms can detect sudden changes. Some pros of this include improves accuracy, generates reports, and can reduce time spent in investigations. And as Isaac just said, gives more time for the company to work on other things. With continuous learning, NLP can become more accurate with identifying possible fraudulent transactions. And it can also look over volumes of data and detect and prevent fraud. Along with this, it's believed that they'll soon to be analyze unstructured data, things like emails, chat logs, and social media posts. All those things will be checked for suspicious activity and behavior. Moving on, going over to blockchain technology, as we see more companies moving to this in the future with cryptocurrencies and things like that, just because they provide transparent ledger, they store transaction data, and they have a secure environment. We can see AI being able to like power up with them and analyze activities inside these systems. With that being said, AI technology is not enough to prevent fraud. We also see a lot of threats. Even now in 2024, fraud is very prevalent with the amount of AI. One of the most common being wire fraud. Wire fraud is during the closing of a deal or transaction in a company, the funds intended for a transaction are diverted into a fraudster's account. We see this happening a lot, even with the AI fraud protection. And today, 1 in 10 consumers become targets of fraud, and 1 in 20 become victims to wire fraud specifically. Along with this, they're also vulnerable to different attacks. We've touched a little bit on these, but like phishing attacks and email compromises, a lot of things that companies suffer from today. And then also voice cloning, as Luke talked about earlier. They're able to kind of take their voice and twist their words, and then you could use this to get information out of a company. With that being said, fraud protection systems still need to be in place, as human recognition is definitely necessary. Things like creativity and independent thinking are something that AI will never have. And I believe that you'll always need the human independent thinking to protect your company. And then also still taking steps to prevent fraud, things like requiring strong passwords, company-wide phishing tests, and develop data sharing protocols are all good things for this.
Now talking about the ethical standards of using AI to detect fraud. Using AI to detect fraud can be very beneficial, but still should hold the same ethical standards when using AI to detect fraud. So AI algorithms may unintentionally introduce biases, which could lead to inaccurate profiling and unfair targeting of groups or individuals. Having a model performance review periodically evaluates AI algorithms to ensure they continue to operate effectively and efficiently while adapting to new fraud patterns without introducing biases. There's also a risk of breaching privacy when AI analyzes vast amounts of data, including sensitive personal information. Ensuring that privacy regulation is followed is crucial. Having security and privacy audit assesses the security framework protecting the AI systems and the data they process to prevent breaches and unauthorized access. AI systems should be transparent in their decision-making processes, should be explainable, and maintain trust among users and regulators. One way to be transparent is to leave an audit trail for decision makers during fraud investigations. There should also be clear accountability for AI decisions, including outcomes produced and data used, especially when they have significant consequences for businesses or individuals. AI used in fraud detection must comply with existing legal frameworks to ensure that the safety and security of financial operations. Having a regulatory compliance check verifies that AI applications comply with current legal standards and ethical guidelines, especially in handling and processing sensitive financial information. Data security includes protecting the AI systems and the data they process from breaches and unauthorized access. To do this, AI systems require accurate data, role-specific access controls to safeguard personal financial information, and clear retention policies for data deletion. This is essential to maintaining integrity. And then some case studies on using AI to detect fraud. The first case is banking. AI can monitor transactions in real time. So for example, if your card has a transaction from a foreign country, AI can flag that and deem it possibly fraudulent. And if it is fraudulent, then they can freeze your card, which can be a benefit if then your card was being used in fraudulent activities. But if you're in a foreign country, that can also be an issue because now you're in a foreign country and your card is frozen. And then another case study can be healthcare, where AI can detect fraudulent insurance claims and prescription fraud, where they can do this by analyzing billing data to identify irregularities. And then the third case is insurance, where AI can identify possibly fraudulent claims. So if an insurance claim is made for an accident that's made after the policy was canceled, AI can flag that and deem that fraudulent.
So the cost of implementing AI to detect fraud. So the AI fraud detecting business is a $6.5 billion industry and is projected to grow up to 10 billion by 2027. So for implementing AI in companies, consulting, it's a pretty expensive process, but consulting can start up to $400 an hour, depending on the size and magnitude of the data that you have. So if you decide to go with a third-party AI software and just like buying one, like a generic AI detection, it can be up to $400,000 per year. And if you decide to go the custom AI software route and because you need XYZ specifically for your company, it can be up to $500,000 a year or more. And along with this, there are maintenance that needs to be done on your programs because fraud is always evolving and there's more data coming in every day. So outsourcing is significantly less expensive than insourcing your not manufacturing, your maintenance. And so like keeping it in-house, you definitely get a higher quality, but it is more expensive to keep people on labor wages. And along with that, like the biggest like point to this is that it really truly just depends on the company size and the data size, and these prices can very much fluctuate depending on how much data you have.
And then just kind of wrap up the last points that we wanted to make. As we go into the future, things like AI, we know that this is growing better every day. And we can also see it being used in different systems, as I talked about the blockchain technology, something that we want to see in the future and definitely companies will take into account. But with that said, the threats, we see this more as a tool and not entirely not to prevent fraud entirely. We see human intervention will always being necessary. Things like I talked about, like independent thinking and the creativity that humans have, I don't think is something that can be replaced. Along with that, the benefits of AI detection, definitely a lot here, but we want to talk about the real-time detection. You're able to explore data faster and more thorough, and it saves times for employees and later for the company. Thank you.
So I just want to split some hairs here because that's what I do. So can you go back to the slide on the different programs? I think it's like Veto and Veto Comply. That one right there. Your title of your presentation talks about AI fraud detection, but it seems to me like a few of these programs you have listed up here are more preventative programs. Would that be an accurate statement? I'm not
Um,
gonna count off points on this, by the way. I'm just wanting clarification.
I mean, yes, I guess technically, but also though, like, if, like, they prevent and it's like a preventative measure, but it is also a detecting measure as well. So like, once it is detected, it's flagged and that user is frozen as.
Something that, Nishant Majaria said to us a few weeks back when we were talking about, AI. He said that the AI tool itself, the AI algorithm is only going to be as good as its development. Is there a possibility that if we have, the manipulation of AI tools, specifically those like reinforcement learning, because that was one that you focused on in the presentation. It's gonna work by trial and error. And if it gives bad feedback, but say, no, this is a fraud, but something actually doesn't occur, it will reduce the effectiveness of the AI tool.
I think, yeah, definitely, but with the trial and error, I think that if the person that's kind of coding it or helping it along can tell it that this is wrong or right and what it wants to get out of it, that's definitely, it can kind of fix itself. As you said, the reinforcement learning, it can grow better as you use it more and then show it what's right and wrong.
Obviously, privacy is a really big issue, particularly when we talk about the use of AI. This goes back to like old social contract theory, which is well outside the scope of this course, but there's always been a view of the trade-off with whenever you have security versus freedom. Do you think AI is going to kind of exacerbate that problem, or the use, specifically the use of AI in fraud detection, will exacerbate that problem?
Yeah, that is something you have to think about, is like if you're kind of like incurring on people's privacy, like is that a problem? But also you want to like work to prevent the main issue of fraud. So I think there is a fine line definitely of infringing on people's, privacy and like data that should be seen and not, and then also working to prevent fraud and benefit the company.
And this is something that's really interesting to me because I worked in fraud for a very long time. We tend to compartmentalize the definition of fraud very, to a very, very small scale. We say that there's financial reporting fraud, there's theft, misappropriation assets. We also talk about corruption. It seems to me, though, that some of the things that you talked about are so far outside of the scope of any of these definitions that we will need to expand our definition of what fraud really represents. Could you, this is actually motivated by the fact that 5 of you are on sports teams at Truman State, but so you see that there being an issue with like image and likeness issues with AI deepfakes in the future?
I would definitely say yes. I know like online, like you see like deepfakes of like people singing already, like AI is already like creating a bunch of stuff that people did not think would be created as of now. So I feel like in the future it could definitely be worse.
And I think like right now you can kind of look at it and it doesn't really look like a normal human would, but I think in the future as this technology gets better, it's something that, like you might have to really look into and see if it's actually like a deep fake or it's a real person.
Yeah, and I also think that like a lot of that like stems from social media. And so I think that like companies like Instagram and Facebook and Twitter are gonna have to start implementing AI fraud detection within their software in order to get rid of that.
Any other questions? John? All right, team machine learning, you are up.
Okay, we decided to look into machine learning. I'm Kylie.
I'm Sophie. I'm Grace. I'm Meg.
I'm Chandler.
So what is machine learning? Machine learning involves the computer's ability to learn from experience rather than specific instructions, and can also be explained as the capability of a machine to imitate intelligent human behavior. And then there's two applications like we learned in class, classification and regression. So classification assigns the data labels, like putting it into certain groups or saying yes or no to it. And regression seeks to predict to predict real numbers, like say a price of a house or something. And then there are 4 types of machine learning, again, like we learned in class. So supervised is when output is a known set of values. And then semi-supervised is when the data is labeled, but it can either be missing or incorrect. And then unsupervised is when the output is unknown. And then there's reinforced learning, which is when the machine learns by trial and error. Then here are some examples. So first we have ChatGPT, which I think we all kind of think about right away when we talk about machine learning. And we'll talk about this more in our presentation, but it uses unsupervised learning. Then we have self-driving cars, which I feel like some people might not think about immediately when we talk about machine learning. But self-driving cars use machine learning to interpret their surroundings, make decisions, and ensure safety. And then they use reinforcement learning, which is a little worrisome because they have to learn by trial and error, meaning there are errors. And then there's social media, which uses machine learning to identify and predict relevant content for each user. So kind of make everybody's feed unique to them and show you what you want to see and take away, but obviously you're not interacting with. And then for this one, it's a little tricky to figure out exactly which type they use since there are so many different platforms. But most of them use unsupervised learning. And then some of them specifically focused on YouTube use reinforced.
So the background of machine learning goes back a lot further than you might think. Machine learning history is said to have started in 1943. There was a paper that explored the first mathematical model of neural networks. And that paper was called A Logical Calculus of the Ideas Immanent in Nervous Activity. And then in 1950, Alan Turing developed a test that would test a computer's intelligence by seeing if a computer was able to fool a human into thinking that computer was a human. Turing wrote a paper on this test and asked the question, can machines think? Which is kind of the answer that machine learning is trying to answer. And then in 1952, Arthur Samuels developed a checkers game through IBM. It was a program that would remember the positions that it had and would use the minimax strategy to try to minimize the loss. And it would memorize the positions that it had moved to and would use those positions with the reward system to see how it could continue to get better at checkers using reinforcement learning. And then in the 1960s, the discovery of multi-layers showed that using 2 or more layers would offer a lot more processing power. And this led to backpropagation, which basically lets networks adjust hidden layers of neurons to adapt to new situations. And backpropagation was used to train deep neural networks, which is how deep learning was able to start. And then in the 1970s and the 1980s, machine learning really started to separate from AI because neural network research was abandoned by AI researchers. And this led to machine learning to be recognized as separate fields. Now the goal was to solve practical problems instead of training for AI. And machine learning shifted from being more knowledge-driven to being a lot more data-driven, just because of how much more data was available on the internet. And in 2020, OpenAI announced GPT-3, which is able to generate human-like text when it's given a prompt. And like Kylie mentioned, social media like My AI on Snapchat uses GPT-3, and I think now there's GPT-4, and ChatGPT also is an example of a program that uses GPT-3.
Now let's talk about what's happening with the machine learning right now and how is it making difference in today's world. Advancement in machine learning algorithm. Machine learning algorithm forms the backbone in the application or system. In 2023, we have witnessed a significant advancement in machine learning algorithm. It's like teaching computers to understand things in advanced way. It has become really good at recognizing image, understanding text, understanding speech, and processing text. Application across industries. Machine learning is being used in different industries and jobs. It's not just for the tech companies anymore. It's everywhere. Doctors are using it to diagnose treatment. Banks are using it to detect fraud. So it's not just limited in the tech companies. Healthcare. In healthcare, machine learning is transforming diagnosis and treatment. Computer programs are helping a doctor to see the inside body better. They look at MRIs and X-rays and use smart technology to know what to find any problems. And this helps doctor make sure they know exactly what's going on with the patients. Growing adoption. More and more people and businesses are using machine learning because it's really helpful. We all are familiar with ChatGPT. It has made our life so much easier that machine learning is becoming more popular than ever. People are using it in all kinds of ways. Even business are using it everywhere. With more and more people saying how helpful it can be, machine learning is really taking it off.
So there's a lot of advantages and disadvantages to machine learning, but first we'll go over the advantages. So automation is like the main one, that it lets machines make predictions and then that improves the algorithms. So like an example of that would be like antivirus softwares. They like filter in and out new threats and they can just do that like automated, whereas like a human, it would take a lot more time. And then scalability, machine learning is able to handle large data sets, which humans probably can't. And then they are also able to work in dynamic and uncertain environments. And then for improving efficiency and accuracy, it reduces the time to process and analyze this data, especially if it is so large. And then it's able to detect issues that humans can't. And then for identifying trends and patterns, it helps a business understand, like, if you're looking at from like an Amazon aspect, like who their consumer is, and it kind of like puts products like related to that person, which in turn makes you purchase them more. And then some disadvantages would be interpretations of results. Although like we all like use machine learning with chat and everything, it can never be 100% accurate. It just, there will always be some degree of inaccuracy and there's just no way of stopping that. And then there's high error chances. So machine learning is dependent on two things. It's dependent on your data and your algorithm. So if either of those two things are messed up, then the outcome will also be messed up and it'll have repercussions with your answer. And then data dependency, it's dependent on like data sets, like you need it. So if you run out, you'll have to wait for more data to come in and that may take a while. And then privacy and security issues. There's a couple of lawsuits going around right now, big firms where they've been like collecting data of people without permission and without their knowledge, and they've been using it for commercial gains.
So looking into future considerations, we can see that I chose cybersecurity. You might see some overlaps from the previous presentation, but machine learning being able to shift through a lot of large data sets that otherwise would be very difficult for humans to helps it, and being able to distinguish patterns helps understand where programs might have malicious issues or be able to detect fraud as we saw. And we can see a lot of areas of machine learning being progressed, being able to be preventative, being corrective, and even detective. So, and then continuing into the ideas of the ethical issues that are arising from machine learning, we could see a lot of people worrying about privacy, and that can only get a lot more difficult as we implement more abilities of machine learning into our daily lives and programs. And then we could see job placement, displacement being an issue. A lot of people are worried about losing their jobs because these systems perform better than them, but we could also see it being a double-edged sword because people are able to get jobs because they're able to implement these types of systems and be able to create them. And then another ethical issue we can put insight into is the laws and regulations that take a very long time to be in place while the machine learning is developed at a faster pace than that. And that kind of correlates with the issues of privacy. We can't get the regulations to get the privacy that we need. And overall, we can also see another integration of AI, the rule-based, and then machine learning, the database, and put the two sides of that type of brain together and be able to solve more complex tasks and issues.
Okay, for the machine learning applications, since everybody was talking about the ChatGPT, which is machine learning based on the text learning, so I'm not going to repeat it anymore. So, and today I would like to share two different examples with you guys, which are both the machine learning based on the image learning. The first one is a Tesla FSD full self-driving. It's using neural networks through the supervised learning to process visual data from the vehicle's multiple cameras. If we look at the pictures over here, we can find out that Tesla has already recognized the types of the vehicles, the distance between two vehicles, and the road makings. Also, the FSD using the reinforcement learnings to optimize the driving strategies. It's usually avoid the pollutions and reduce the travel time. Plus, if we use the navigation system on the Tesla, it can also tell us when we should go to the charging station and how long we are going to spend for charging. And also, I would like to share a news with you guys. That is recently, the Elon Musk has come to China to talk about the FSD sections. He's trying to make the FSD legal in China because before that, the Chinese government, they won't allow any high-level self-driving vehicles legally on roads. So Tesla will be the first one. And I think this will be a big step for the self-driving vehicles in China. And for the next examples, I believe every gamers have already heard of the NVIDIA DLSS deep learning super samplings, which is manually under the category of supervised learnings. During the development of the DLSS, a large amount of the processed data was used to train the deep learning models. So when we enable the DLSS, the low resolution images will constructed with the high resolution details, which is said to not only increase the FPS, but also preserve the details of the images. Although these technologies has already run for several years, I think the NVIDIA still needs to work better on it, because nowadays many peoples and gamers, they just don't dislike the DLSS. They don't turn it on while they were playing games. So if the NVIDIA could do better to realize their promise to truly boosting the FPS and without decreasing the image quality, I think this technology will be really improves the people's willingness to buy a new graphic card which can use the DLSS functions. And that will be all for the application parts. Let's move into the samples.
So the concept of machine learning is dates back as far as the 1950s, which the street view just like this. And over time, as algorithms, data abilities, and computation power have evolved, it becomes more and more important and the most active area in the AI researching. So machine learning technicals are now using a wide range of fields such as financial service, healthcare, automotive industry, customer service, and many more. Like Xinjie just talked about the self-driving stuff. Even video games has the machine learning tactic. And I do think it's really close with our life. Just like right now, the picture I just showed you guys was created by ChatGPT 4. which I give the order to create. And the next two example will be more clearly what machine learning is. Next. Okay. So the first picture, the order I gave to ChatGPT was, can you create a picture that a college student use ChatGPT to create some assignment or homework? And it's just give me this picture, which is not good enough. It's good, but not good enough because it's just a college student use computer. You guys are taking notes with just like this. So I just gave a second order, which only 3 words is not good enough. I said not good enough. And it comes the second picture, which much better. It's switch of view. It actually shows this guy is using ChatGPT to create some assignment with just 3 words, and the back work ChatGPT did improved a lot. So overall, thanks. Overall, machine learning is a fast-growing field that has greatly advanced in AI technology, which has advantages and disadvantages. However, we must be careful with all the AI stuff and machine learning stuff. We want to be a high technology environment to improve our work and study stuff, but we do not want the AI was always watching us and steal our privacy stuff. Future development of machine learning will require a balance of construct and evolve and the responsibility. That's all I want to see.
Let me go back to that ChatGPT image.
Which one?
That one right there, yeah. I'm blown away by the guy's hairstyle. They actually changed the hairstyle in the picture on the right. I guess you would say not good enough and saying, well, we gotta change the pictures about the individual too. I'm sorry, it's terrible. That's my takeaway from the presentation. It's a really good presentation. One of the things that I think Kylie said at the beginning was that we characterize ChatGPT as a kind of an unsupervised learning tool. And some of the research I looked at said that it's a reinforcement learning tool. Now, I'm not saying that you're wrong. I guess this kind of leads to an interesting implication. Is there a possibility that it's too easy to kind of say pigeonhole something into one lane and say there may be machine learning tools that fall in multiple categories?
Yeah, absolutely. I'd say most of them probably use all of them in some sort of way. So it just kind of depends which one you look at it from.
And I think the allusion was made, and I just want to get some clarification. What is the primary difference between machine learning and AI?
I think so originally machine learning was kind of a way to make AI better as it was learning more. And I think just the difference now is machine learning is more just focusing on like the data, and AI is just more focused on it's just different fields. It's grown.
It's our definition to come up with.
Yeah.
I think that we tend to view machine learning as a subset of AI, but saying that AI is machine learning is the same thing. That's a little too common. And I do believe that the demo, because I think the early part of the presentation said that AI kind of abandoned the neural network development path, but that's a really common feature of machine learning tools, trying to emulate human thinking. Which leads to an interesting question. And I know that this is the doomsday scenario that you've probably heard from a lot of instructors. I'm not going to be one of those instructors, but I am going to be for this question. Okay. So do you think that there's a possibility that the advance of machine learning could impede the development of human learning?
Yeah, for sure. I feel like people may become too reliant on like just getting answers from a machine rather than learning it themselves. And I feel like school is a good example for that, where like we've all probably used ChatGPT or something rather than just like doing it by ourselves. But like as you pointed out in one of your lectures, like they're not always right, especially with like the accounting, like the journal entries, like they were so wrong. But like we might become dependent on that information.
It's okay, sometimes I'm wrong about that. Not a good admission to make, but there you have it. The self-driving cars being a reinforcement learning tool, I think that's got an interesting stigma associated with it, but let's just put this in perspective. Let's say that you're about to turn 16 years old, you've got your learner's permit, you're driving around with a family member, and you take a wrong turn or you fail to stop at a stop sign. Do you think that the world is gonna freak out and paranoia and say, oh my gosh, that they'll never learn, they'll never be able to adapt or fix the problem? Or do you think they say, well, that's just part of the learning process? Why is that different for machine tools then? If we accept that humans have to undergo trial and error as part of their learning process, why are we why do we have such a problem with machines doing the same thing?
I think so you go.
I would say when you spend a lot of money on that self-driving car, you hope it can kind of drive better than a 16-year-old who just got their license. But I do understand, like, they had to go through the same, and it's not a huge deal.
I mean, I would assume most parents spend a lot of money on their 16-year-olds. It seems like a little bit of hypocrisy to me for us to say that we do not accept that we assume that machines are going to be perfect from the get-go. Do you think that that's an oversimplification of this particular situation with machine learning, that machine learnings are not tools, machines, computers, whatever the term you use, are not perfect and they have to learn just like humans do?
I think so. I think it could be like a larger scale though, in a way, because it's like, you know, I think if the computers, like, if there's a big like network that, you know, all of a sudden, like, there's all these self-driving cars that have a problem if there's like a bug in the system, I think that could be such a larger scale than like one 16-year-old making a mistake, you know, because they're all like in a way more connected. So, you know, that could be a problem.
Any other questions? Good job. All right, one more presentation, guys, then we're done for the semester. Thank you very much, and I'll see you all on Friday.